Welcome to Anything Maths. This video deals with work examples on motion with constant acceleration. Like the video and also subscribe to the channel. The first question is, a train is traveling with a constant acceleration along a straight track. At time t is equal to 0, the train passes point O, traveling with a velocity of 80 meters per second. At time t is equal to 12, the train passes point P, traveling with a velocity of 24 meters per second. At time t is equal to 0, the train passes a point Q. Find the speed of the train and also the distance from P to Q. Now, dealing with mechanics is really important to put the information in a diagram form so that we'll be able to see what is going on. That is exactly what I'm going to do. First of all, at time 0, so I'll put 0 here. Then we have time 12, and then we have time 20. Okay. At time 20, at time 0 is O point times 12 P and times 20 Q. And the velocity at O is 18 meters per second. The velocity at P is 24 meters per second. And we don't know the velocity at Q. The question is, we're supposed to find the speed of the train at Q. It's quite clear that we need to find the acceleration. From the question, we consider the first part of the journey between O and P. It's quite clear that the initial velocity U is 18. The final velocity will be 24. We don't know the acceleration, but we know the time to 12 seconds. And therefore, we can use this equation. V should be equal to U plus 80. Because we want to find A, we make A the subject. So you can A, U, V minus U, all divided by T. Make the substitution. 24 minus 18 all over 12. And going to be 6 over 12. Get half. So half meter per second square for the acceleration. So we have the acceleration to be half meters per second squared. What is the speed? And we can use the same formula to find the speed, because now we know the acceleration is just a matter of substituting the value. So V should be equal to 18 plus half 20 seconds, and we're going to have 18 plus 10, 28 meters per second squared. So that is the answer for A. What about B? B, the distance from P to Q. So the initial velocity this time will be 24. And we know the time it took, which will be 20 minus 12. That will give us 8 seconds. So I think everything is set. We use this equation. S should be equal to UT plus half AT squared. We're going to have 20 times 8 plus half times half times 8 squared. So you have to use your calculator. 64 divided by 4 plus 24 minus 8 plus 8. You get 208 meters. Correct. It's not so difficult. Now the next question is, a ball is projected vertically upwards with a speed of 21 meters per second from a point 32 meters above the ground. Find the speed with which the ball strikes the ground and the total time for which the ball is more than 40 meters above the ground. And we are supposed to sketch the velocity time graph. So as always, I want to do a sketch. So that's the sketch I've done. The ball is at this top and hits the ground again. So the first question you have to ask yourself, what is the displacement? The displacement is negative 32. Okay, giving you the initial velocity. The initial velocity is given as 21. A will be the same as G. Okay, but I'm considering going up to be positive. So it means G will be negative. Okay. What we can do, we can use this formula. V squared should be equal to U squared plus 2AS. We know U should be 21 squared. Then we know that plus 2 times negative 9.8 and then times another negative 32. Okay, so let's find that. Use our calculator. Plus 21 squared. You're going to get 5, 3, 4, 1 all over 5. It implies V will be the square root of that. It implies V will be the square root of 5, 3, 4, 1 all over 5. Find the square root of the answer. And I'll get 32. I'll get 32. So V, the V will be 32.6833 and continues. And to 3 significant figures is going to be 32.7 meters per second. So that is the equation that will strike the ground with. The next one is the total time for which the ball is more than 40 meters above the ground. There are so many ways to do this. I'm going to work it out this way. When we add 8 to 32, you're going to get 40. So imagine from where it was hit, from here to there, that place is 8. Okay? So we know the initial velocity. We want to find the velocity when it got to 8 meters from that point of projection. Okay, so that's what we want to find. So we want to find that velocity, and we have to use this formula. V squared should be equal to U squared plus 2AS. Okay, now we know that G will be negative because you are considering going up to be positive in this question. We're going to have 21 squared plus 2 times 9.8, which is negative, times 8. Okay, let's see what you're going to get. You're going to get 21 squared times 9.8 times 8. I'm going to have 1421 all over 5, and then velocity will be the square root of that, and that gives us 7 root 145 all over 5. Nice and easy. So now we know the velocity at this point to be 7 root 145 all over 5. That's an important information. So what we're going to do, imagine yourself being at this point, okay? And the ball got to this point and came back to where you are standing. It means the displacement at that point, let's say this is x, will be 0. So x will be 0. And also u, because at that point we are taking it to be the initial velocity, u will be 7 root 145 all over 5. And as a result, we can use the formula. It's going to be 0 root of 145 t minus half, okay, plus minus 1.8 t squared. Okay, and what are we going to get? We're going to get 0 should be equal to 7 root 145 over 5 minus 4.9 t squared, and we can factorize the t out, so we can get t into bracket 7 root 145 over 5 minus 4.9 t should be equal to 0. So that's what we have. So from this equation, t will be equal to 0, that's the starting point, and 7 root 145 over 5 minus 4.9 t should be equal to 0, and therefore t will be 7 root 145 over 5 times 1 over 5. Use your divide by 12.5. You're going to get 2 root 145 divided by 7, and it's going to give us seconds, or you can leave the answer this way, or you can write it as 3.44 seconds. So that answers the second part of the question. From our previous calculation, we know that the final velocity is 33.7 seconds and the initial velocity is 21. Okay, but the initial velocity goes up, the final velocity comes down. So in case to indicate that, imagine this is 21. There is a velocity, so meters per second, and you have time of x. So what happens is this will be a straight line. Can draw the straight line well, and you have 33 here, point something of what you have, and you have to find the time it got to 0, the time that the velocity is 0. How do you find that time? We get that time from using this formula. U V should be equal to U plus AT. When V is equal to 0, we're going to have negative U should be equal to negative 9.8T, and therefore T will be 21 over 9.8. Okay, so 21 divided 9.8, you get 15 over 7. So this intersect the graph 15 over 7 seconds here. So that is the velocity time graph for this particular motion. The next question is, a train starts from rest at a station A and accelerates uniformly at 3x meters per second until it reaches a velocity of 30 meters per second. For the next t seconds, the train maintains this constant velocity. The train then decelerates uniformly at x meters per second and decelerates at s meters per second squared until it comes to a rest at a station B. The distance between the station is 6 kilometers and the time taken from A to B is 5 minutes. Sketch the velocity time graph to illustrate this journey. So first of all, start from rest. So it's going to start from a 0. Let's label our velocity time graph meters per second. We're going to have t of seconds. We go to 30, so we put 30 here. We move to 30, move another t second, then come down. From here to there, we can say this is t1, and we can say from here to here it's t big T. Going to have t2 here. It uses 5 minutes. So 5 minutes If you convert 5 minutes to seconds, it's going to be 300. So we know now this is 300 seconds. So question A is answered. We're supposed to show that 40 over x plus t is equal to 300. So first of all, we know that t1 plus big T plus t2 should give us 300 seconds. From the equation, from the information given us, the first t, we know the acceleration is, so we can say 3x should be equal to the change in velocity, which is 30 over t1. And therefore, t1 will be 30 over 3x, which then becomes 10 over x. The last is x, so it's going to be x should be equal to, x will be equal to 30 over t2, and therefore t2 will be 30 over x. So we know the t1 and the t2 now. So let's put it in the first equation we wrote, t1 plus t plus t2. From the calculation, we know that t1, 10 over x, plus t2 is 30 over x, should be equal to 300. Simplify everything, we're going to get 40 over x plus t equal to 300, just like as required. Find t. We've been given the distance between the two stations, so we can write 6,000 is the same as half t plus 300 times 30. Why can we write this? Because we know that with velocity time graph, the area under the graph represents the distance covered, and this is a trapezium, and it's going to be 6,000 divided by 15 should be equal to t plus 300, and therefore t will be 6,000 over 15 minus 300. Take your calculator and do the work. So we have 6,000 divided by 15 minus 300, got 100. So this the capital T is 100 seconds. Thus, we substitute the T in that equation and solve for x. So let's do that. T is 100 seconds. So you substitute in 40x plus 100 should be equal to 300. 40 over x should be equal to 200. and x will be 40 all over 200, which will be, this will cancel that, get 1 over 5. That's what x is all about. The D say calculate the distance the train travel at a constant velocity. So at a constant velocity, we can say that is the rectangle. So the distance is simply, we know that the length is 100, which is 100 seconds, and the height is 30. So basically is 3,000 meters or 3 kilometers. Okay, it says calculate the time taken from leaving A until reaching the point halfway the station. So let's cut here and let's call this from this point to that point. Let's say it's T3 because we don't know. We can now calculate T1 because when we work, we realize that T1 is 10 over x, and we got x to be 1 over 5. So it's going to be 10 all over 1 over 5, and therefore T1 will be 50 seconds. Okay, so it means from here to here will be 50 plus T3, and because it's halfway through, this first part is also a trapezium, and as a result we can say 3,000 should be half of 50 plus 3t plus T3 times 30, which will give us 3,000 divided by 15 should be equal to 50 plus 2T3. Let's simplify. 15 will go to 30, so you're going to get 200 should be equal to 50 plus 2T3. So 2T3 will be 200 minus 150. So you're going to get 2,3 should be equal to 150, and then 4,3 should be 75. Okay, and therefore the time it took, which we know is 50 plus 3t, will be 50 plus 75, and that will give us 125 seconds. That's really cool. So when you are solving these questions, you just need to be careful and solve them. This brings an end to the video on work examples on constant acceleration. Like it, subscribe,